We're now ready for substitution, integration by substitution, example 1b, all right? Now look, we've talked a lot about algebra rewrite, but to apply that power to that group, given the fact there's subtraction, you don't want to write that thing down 7 times and distribute for an hour and a half. So that would be a tip off to you that you want to do substitution. And as suggested, if we have a quantity being raised to a power, then that should be typically what we will substitute for. So the single variable u will take the place of that expression there. And so on this new integral that we're going to run off and work, this would become u to the 7th. Yay! All right? So that's easy. Now, but here's the part, you got to be creative, I think. So here's what I always tell people. Once you make that original substitution, anything else that's in this original integral will be built from this. Every time, the next step, in my opinion, would be to build a dx from this. That's the motivation behind differentiating both sides with respect to x. So, this side becomes du dx. Derivative, that's 0. Wouldn't this be -3? With respect to x, right? With respect to x. Clear fractions. Okay, so dx on both sides. And it turns out that du would equal -3 times dx. Now here's the thing. We took the derivative of both sides with respect to x because we wanted to get a dx into the discussion, and we always will. But here's the thing. That -3 that fell in our lap, so to speak, is nowhere else to be found in the problem, in the original. So this is where we need to be creative and make some adjustments. So unlike the previous one, we got something extra that was not in the original problem. As a matter of fact, isn't there a 1 up here? So the question becomes, I just want 1 dx. We just want 1 dx. We don't want -3 dx. So we look at it this way. Here's how I think it through. So how do you change that -3 into a 1? We want this to match what the original problem was. I look at it this way. How about we divide by -3 to make it cancel and replace it with a 1? In other words, multiply it by -1/3. Won't that change that into the 1 that's in the original question? This is where creativity comes into play. If something falls in your lap, you got to sometimes make adjustments to make it equal the original question. So we will take this expression and multiply both sides basically by -1/3. And so it turns out that -1/3 du will equal 1 dx, otherwise known as dx. And there's the dx in the original problem with the implied 1 up here. And so I would just point out that that dx is now equal to -1/3 du. And so these two things take the place of that dx. I've always felt that when you have a multiplier, a numerical multiplier such as 1/3, -1/3, that it makes sense to just put it in front of your integral. And so my point is the dx in the original question got replaced with -1/3 times du. Kind of pull them apart a little bit. So, yes, sometimes after you take that derivative, you might get something extra in your lap, and if you don't want it, be creative. Do whatever algebra and manipulation you need to do to make it match the original question, okay? Remember, there was a 1 there. So, this new integral, we hope, if we did things well, would be easier to integrate. So we've got that multiplier up in front, and then we do the power rule. Well, that's cool. U to the 8th over 8 plus c. We're back to, I want to remind you, indefinite integral. We don't have limits of integration here. I would recommend one more thing would be to clean it up a little bit. So for example, this would be -u to the 8th over 24 plus c. That's just arithmetic, clean up, right? Okay. And now it's real easy though to remember that you ran away with u and integrated and everything. But the idea would be you want to always go back, substitute back, all right? And So the point would be, so you're just kind of using u temporarily, okay? And then you run back to your x, so again, u was equal to that expression there, so we have negative expression that u took the place of, to the 8th power over 24, see this, right? What did u take the place of? Substitute it back, and then always remember the plus c. Now, after all that work, I'm supposed to count it wrong if you don't put the plus c there. I don't want to do that, so please don't give me that dilemma of deciding whether to count it wrong because you forgot the plus c, all right? So remember, on an indefinite integral, your answer is a math expression with that constant added on. All right.